Hi, good morning. This is to introduce the lab, which is energy conversions. Okay, I will share with you now my screen where I have the lab. This is really the, like going to the learning modules. This is the lab that we are going to start working on this week, but I will say next week is going to be the spring break, then we will not submit that lab. And also the week after, we will not have a lab. And because we are going to have two lectures next week, after the spring break, we're going to have two lectures. Now, then this lab is not going to be due until March 27th. Okay, you have plenty of time to work on it. Now, also after the spring break, I will be out for the week, and then I will have chapter 6 and chapter 7 recorded for you. Then you are going to find these ready for you after the spring break. You're going to have a quiz for chapter 6. You're going to have a quiz for chapter 7. You're going to check these yourself and work on these and communicate with me through office hours if you have any questions. Now let's go for the lab. Okay, then after, of course, you will view the video. You will be having access to the homepage where, of course, I have the submission. I have the rubric. Please always check the updated rubric. Also, you should have, two files for this lab. One of them is going to be the Excel sheet, and the other one is going to be the I would say the formal lab report. Now, we are going to use Beyond LabZ for that. And of course, through this lab today, we will be able to understand connections about energy, about conservation of energy, and we will be able to calculate the gravitational potential energy for an object. And we are going to also calculate the gravitational potential energy, the kinetic energy, and the total mechanical energy, and provide an evidence that energy is conserved. This is I will say the instruction page, and of course I will go with you through the steps of how we are going to do things. And as I said, we need, of course, the Beyond LabZ. Then I will, I quit it, but I will be able to get it again. The portal. Okay, hopefully I'm still in. Okay, no, I need to log in again. And just always, as I said, follow exactly what I will have in here. Desktop, open. When you open the virtual physics, you will find the lab under energy. Here, this is energy conversions. And then it will open in the energy lab. Like I will say for the data, collecting the data, it's just one click and that's it. But the thing is, I want you to change here, from here, the mass of the object to be 2.5. Okay, then can you see here? This is kilograms. This is the diameter. We don't want to change it. This one here, you're gonna change it to 2.5. Okay, kilograms. And don't forget to have the recording, and then force, and that's it. This is how we are going to do the experiment. Okay, then this is our experiment. Now I will, okay, again, if you need to change the mass, you're gonna hit that, okay, the parameters. Can you see it? And it will show you this one. Now I'm done with my experiment. I will open, it's just one data file, copy, and then I will go to my Excel, okay? Okay, then here, what I have is my file. I want to show you maybe what we need to do here. I will paste my data here. This is the time. This is the X component for the motion, the position. This is Y. This is Vx. This is Vy. And I don't care actually about the rest. I might get rid of, like I don't need these, then I can easily delete. Okay. Now, I need here more than one thing. First, the velocity here is provided you as Vx and Vy. Then I will first calculate V. Okay, V, it is meters per second, and is going to be equal to, you're going to get the function square root, insert that function, and then here you're going to say Vx squared plus Vy squared. Then here I have calculated my, okay, my velocity. Also, I need to calculate my gravitational potential energy, and this is in joules, and that is going to be using M, okay, which is you're gonna use the value of M that you have. Okay, let's assume for me I did choose 0.5. For you, you're gonna choose, you should have it 2.5. Okay, then it's mass times G, which is 9.8 times with the Y, and that is my gravitational potential energy. Then I will have my kinetic, and the kinetic is gonna be, okay, the kinetic is going to be equal to 1/2, which is 0.5 times the mass. In my case it is 0.5, in your case it is 2.5 times velocity, and I need the velocity vector, the speed here, the total value of the speed. Then here I have the kinetic. Okay, now I will here finally find E, and that is, I will not take my value in the graphing, the first one, okay, because it is 0. Then I'm gonna consider, then these are the values that I will consider. Now here I want you also to calculate the percent difference. You're going to make this one your, I will say, reference value. Then I will say here I will take the difference between this value and the next one, or whatever it is really like. Okay, I can say this is minus, let me take the absolute value, Okay, let's have it, you know, I don't want to have it very complicated. Then let's have this one minus this one first. Then this is the difference. Okay, like I will do this in steps. And that one is gonna be K7 minus K6. No, I don't want this. I want always to have that K5 minus K4. Then I'm gonna make this here with the dollar sign. So that always is gonna be taking the difference. Okay, and then here. That's correct, hopefully. Oh, this was 4. No, I should have that one here. Okay, because I'm gonna consider my first one. Then I will say this one minus always this one. Then, okay, because always I want to have the difference considering K4 is going to be my reference. Then look here, always it is taking K4 as my reference. Then, and then here, what I will do is I'm going to say this is, I'm going to take the absolute value. I'm not sure if this is the one. Let me see, insert the function and then have this here and see if this is, yes, it's the absolute value. Just I'm taking the positive. And then finally, okay, I'm gonna get this one divided by, again, the one for, from 4. Then I will say it is dollar sign, it was K dollar sign 4. Okay, and this is, okay, I can also, since I want to have it as a percentage, okay, and that is how I will calculate that. Now also, one of the things that I require is I want you to graph here. I can show you my graphs. I want you to graph, okay, the gravitational potential energy versus time, okay? And now you know how to do the graphs. Kinetic energy versus time, and total energy, total mechanical energy versus time. Okay, I want to move the chart into a new sheet where because I want to show you also, like I want to label, I want to have the legend here. I don't know, like here I did not label these. Okay, then I will, okay, I will do, okay, that one, the first one, this was the gravitational potential energy graph. This, okay, and the second one was kinetic. And the third one was total energy. Then here I updated my, okay, and then here I will say, okay, energy, I will say energy graphs over an inclined plane. Okay, now also here I'm gonna have energy, because we have, remember, we have different energies. Then You will not say because it might be kinetic, it might be kinetic, it might be gravitational potential, it might be total mechanical energy, and here time in seconds. And okay, you can see that my graph is reflecting conservation of energy, right? And one more thing, okay, let me check if I have any thing that I want to add. Okay, then for the procedure, we start the virtual physics and select energy conversions from the list of assignments. The lab will be set up with a ramp, a ball on the ramp, and the plunger, like whatever, like is gonna be like using as a driving force. You will hit the recording and then hit the force button, and then the object is gonna go up and go down. You click on the link, copy your data using the parameters icon, change the mass into 2.5, calculate the gravitational potential energy, kinetic, and the total mechanical energy for all positions, a graph, and then on the same chart, you graph all the other, and then calculate the percent. Now, if you can see here, I did say I want to see this, this type of table and the results. Then you're going to go, I don't want you to use the 0, 0. Forget about this. No, I don't want to use the beginning bottom here. I want you to use the first value that we have. Then when I'm looking at the beginning, okay, here, I will highlight this is my first value that is going to be in the table. This is the first one. Okay, and then you're gonna copy just the values that they are needed. For example, here is talking about the height, then the y, the velocity after calculating from the x and y, the gravitational, the kinetic, and e. And then you are going to, okay, like having it at the top, okay, it's going to be something that we are going to do. When it's going to be at the top, it's going to go to 0 velocity, or I will say halfway. Then like you're going to find where is your velocity or your y. Take your y, the maximum values 2.0695. That is, then this is the up. Okay, this is gonna be like always approximate, I will say. And then this is the last one when it is going down, and you need to find a value in between. Then this is maybe 1. And that one is gonna be, yeah, this is like, okay, then here, these are the 5 points of interest that I was talking about. Beginning bottom, middle going up, top, middle going down, coming down, and end bottom. After that, you need to answer all the questions. And don't forget to follow the rubric that we have. And I will say this is what is needed from this lab. Thank you and have a great day.